Hello, welcome back to another video by Learn Computing with Daniel Bullen, with me, Daniel Bullen. So today I am going to go through the October to November 2023 AS level computer science paper via the Cambridge exam board. So before I do, please remember to click that like and subscribe button and remember to spread the link far and wide as you can. And now let's get right into it. So it's paper 2, Fundamental Problem Solving and Programming Skills. It's a 2-hour paper. And the total is out of 75. Let's get right into it. Okay, so you will get given an insert for the list of pseudocode functions and operators which you would need to refer to. So if we go back up, it's going to say, yep, you can't use a calculator. Doesn't say anything here directly about it. So, information here, the insert contains all the resources referred to in the questions. So you'll get an insert for a question like this, and it will help you with the pseudocode. So a shop sells car accessories. A customer order is created if an item cannot be supplied from the current stock. So a program is being developed to create and manage the customer orders. So you've got the following identifier table showing some of the data that can be stored for each order. So we need to complete the identifier table by adding meaningful variable names to it. Okay? So, Mr. Khan, name of explanation, name of the customer. So the variable name we could have is customer name. Okay? So that's what we need there. And our data type, string. Nice and easy. 3, number of items in the order. So I would have num items or even quantity. And yes, it would be integer. So we would have to write it exactly as the pseudocode wants it. True, indicate whether this is a new customer. So you could say new customer as our variable, and it's going to be a boolean. So boolean is true or false. So if you want a way to remember it for boolean, think about it this way. How does a politician not answer a question? Yes or no. They'll never say yes or no. Right, next one. 15.75, deposit paid by customer. So use a keyword deposit. Keyword deposit is in there, and that is going to be a real. For those who do Python or Visual Basic or Java or C# or have done those, a real is what you will call a float or a double. So they will get you 4 marks. So it's going to be 1 mark for each row. So if I was to say customer name in integer, we wouldn't get a mark. If you say customer name in string, that's 1 mark. Go down the list. What I'm showing you now, that would get you 4 marks in the bag. Next question. Other variables in the program have example values as shown. So we need to complete a table by evaluating every expression using the example value. So total times department rate plus 1.5. So the total is 124 times that by 2 plus 1.5. So it's going to be 249.50. So yep, so this is literally primary school maths or elementary maths. The next one is write in description 7. So description 7, so that's obviously going to be 0, 1, 2, 3. So description 7, that would be bracket, small. So that is what we're looking for. So that's description. So write script in description, and it's going to be a small, which is a strange one, as I would have 0, 1, 2, 3, 4, 5, 6, 7. Yes, spaces are characters. So that would be number 7. Okay? And then we want length description minus 8 is greater than 16. Yes, it is. So that's a true. Then we want number. And we want number to string. So it's going to be integer department rate times 10 and the percent. So department rate is 2. 2 times 10, 20%. Bosh. There you go. That's our 4 marks in the bag. Right, the data that needs to be stored for each customer order in part A is not the same type. So we need to describe an effective way of storing this data for many customers while the program is running. So it would be 1 mark per point. So I would say you could declare, so you could compare a record we could declare a record containing all data items required, and we can also declare an array of the given record. So that is what I would write there to get my 3 marks. So you need to declare record, contain all the data items required, and you would need to actually need to declare an array of that given record. So declaring a record, declaring an array of that given record, and containing all of those data items. And you can expand it where the array element represents the data for one order. Right, on to the next one. So we've got an algorithm. We'll input a sequence of integer values, one at a time, ignore the values until 27 is input, and then sum the remaining values in sequence, and then stop summing the values when a value 0 is input, and output the sum of those values. So we've got to draw a flowchart. So you've got your start and you've got your end. So what we need to do, flow of control, nice little rectangle where we're going to set the total to 0. Flow of control, parallelogram, go down again. So we're literally going to go down here, over here, diamond. We're going to go back up here if that's not the case. So we're basically saying, is the number equal to 27? Just enter a number or input a number. So we're going to input, input a number, get another diamond in there. Otherwise, we're just going to set over here, go back up, where after we've set the total to test plus num. So that's that bit. And then what we need to do is go down here. And this is where we're going to put the output total. Normally, I would try and actually do all of the settings and all of the variables as we go along. But because I'm doing it on a computer screen, I'm just going to have to do this. So doesn't matter which way you do it, as long as you do it. So you're going to have set total to 0. So that's what we want. So we want to set the total to 0. We want to input number. Here, we want to say, is num equal to 27? So is that equal to 27? Here, we're just going to say no, which means we're going to go back up and input the number again. Here, we're going to say yes, it is. So that means we go down and we input, guess what, another number. So we input another number. Then we're going to say, is number equal to 0? And then here, we're going to have no. Here, we're going to have yes. So if it's not equal to 0, we go back here, and that is where we are going to set total to total plus num. And then after that, and then once number's equal to 0, we're just going to output total, and here's our end and here's our end. Just by setting the total to 0, that's 1 mark. Just by doing this check, all of this will get you 2. And then the third one, we're looping until the 0's input. Sum of the values after the input of the first 27 in a loop, 1 mark just for outputting the total. So this whole thing, and I'll zoom out. So this whole thing is going to get you 5 whole marks. Okay? And that's literally it. Let's move on. Solution to the algorithm includes iteration. So we need to give one suitable loop structure that could actually be used. So, as we've dealt with whiles, I would say, if you could say pre or post condition, I normally prefer precondition loops. And the reason why I said precondition for 1 mark is because the number of iterations is not known. So we don't know how many times that block of code is going to be repeated, which is why we would do a condition loop, because we don't know how many times that program's going to loop. So I'll just say precondition loops, because the number of iterations is not known. Right. Question 3. So we've got an abstract, we've got a linked list abstract data type. Pointer 1, that's your start pointer. Pointer 2, that's your free list pointer. D4, all of these, they're the data items of node in a list. All of the Fs represent the data items of nodes in the free list. So we've got a linked list is implemented using 2 variables and 2 1D arrays. The pointer variables and elements of the pointer array will store the indices of elements in that data array. So we need to complete the diagram below to show how this linked list shown may be represented using variables and arrays. So looking at the info that they give you and the question, so we know our start pointer is going to be a 4. So start pointer is going to be 4. So what do we do here? But we can't just do that yet. Yeah, pointer was a start. So pointer 1. Pointer 1, yep, that's going to be a 4. Okay. And then what we need to do here is having a look at these pointers. So you've got your D4. You know that says 40. Yeah, so it's going to be 4 because that's the free list. And then number 2, as its pointer array 3, here 1, 2. So you got 3 here. So that's going to be D11. And in index 3, it's going to be D100. And then that's going to be a 0. Okay. And then we've got D40. That's going to be index 1. Okay. And then in index 5, so index 5, that is going to be F1, because that's the first free node. So that's F1. And F1, the free list pointer is going to be a 5. So that's the start of the free list pointer. That's a 5. And the start pointer is a 4. And then in index 7, that is going to be F3, index 7. And then that's going to be followed by 8 in the pointer array. And in number 8, we're going to have F4. Then we're going to have 0. So what we've done, so pointer 1 is a start pointer. So hence you would have a 4. Pointer 2 is a free list pointer. So the free list pointer being F1. So you can say 1, 2, 3, 4, 5, 6, 7, 8. So 8, 7. Then you got 6. Then you got 5 for F1. D40 is number 1. So pointer array 1. And then D100 was going to point to 0. So that's going to be 4. Because that would be 0. 1, 2, 3, 4 is our D100. So you get 1 mark for identifying the start pointer, 1 for each group of rows, and then 1 mark for doing 2, 3, and 4, 5, 7, and 8. So that would get you 5 marks altogether. And then for B, the original linked list is to be modified, so a new node is inserted between the nodes D32 and D11. So we've got to complete the steps. So the steps are going to be, we need to assign data item. We need to assign D6. And we need to assign that to F1. So that's the first thing we do. So we assign it to F1. And then what we need to do is we need to set the pointer of that node. And we need to point that and we need to point that to D11, which is our third one. And then we need to set the pointer point to F2. And then after that, we need to set the pointer of D32, and then D32 will need to point to D6. Okay? Because it's been inserted in between D6, or it's been inserted between D11 and D32. So so it needs to be set at D32, and it needs to point, and then that will need to point to D6. So D11 would need to point to D6. Okay, so that would be our 4 marks. Okay, so question 4. So this is all about pseudocode. So you've got a procedure called count. So that is going to input a value, which are all positive integers, count the number of odd values, and count up the number of even values. Then repeat step 1 until the value input is 99, and output the 2 count values with a suitable message. So the value 99 cannot be counted. So we need to write a procedure called count. So you would get 1 mark just for saying procedure count and end procedure. 1 mark just for saying that, for the heading and the ending. And then we need to declare odd, even, this num, and they're all going to be integers. Odd, that's going to be a 0. They're both going to be set to 0. And then we need to input this num. Okay, that's what we're at, is what we're literally doing. So we need to input this num. And then we need a while loop, so it's going to repeat. So we need while this num is not equal to 99. Then we need a condition where if that's modulus 2 is equal to 1, then we need to have odd. So we are incrementing. So we're incrementing that by 1. Or otherwise, we're just going to increment the C even by 1. And then we need end if. Then we're going to input this num. And then we want to have end while. And we need to output count of odd and even numbers. And that is what we got. Okay? So that will get you 6 marks. So you get 1 mark just for the procedure, starting at heading and ending. 1 mark for declaring the local variables as integers. 1 mark for the conditional loop. 1 mark for inputting this num that's inside the for loop. And then another mark just for incrementing the options. And then 1 mark for outputting for that output. So that is 6 marks in the bag. Pseudocode can be straightforward, providing you know providing you know the pseudocode for your exam board, which in this case is Cambridge. Right, so for B, the procedure count is to be tested. So typical data would consist of odd and even numbers. The purpose of the test is a typical mix of even and odd numbers. And we need to check the totals. So we've got 3 data sequences that may need to be used to test different aspects of the procedure. So it doesn't want invalid data. So test data, we could have a data set with only odd values. That would be 1 mark. Then I would have a data set with only even values, which would need to be terminated with 99. Same when you test out all the odd values. And in statement 3, I would just have data sets with no values, just the final 99. You could have data sets without terminating 99. You could have data sets with all even and odd numbers with just 1 odd, 1 even, terminated with 99. You could have data sets with the same number of odd and even values terminated with 99. But this is what I would have if I was doing this question. Data set with only odd values, terminated at 99. Data set only with even values, terminated at 99. And data sets that have no values, where we're just inputting 99, which terminates the code. Right, question 5. So we've got a global 1D array of integers that has 4 elements. Assigned values as shown. So these are our arrays, or array indexes. A procedure called process manipulates those values of the array. So we need to have a look at this pseudocode for us to complete a trace table on the opposite page. So we need to dry run the procedure when it's called. So if we were to call process 3, so we need to have a look at the pseudocode, try and understand the pseudocode. So what's it doing? So we're declaring 3 integer variables, declared index at the start and a count set to 0. We're going to go in the post condition iteration until the count's equal to 5. And then mix 4 is going to be count times the index. Okay. So this is our table, and that's worth 6 marks. So what we would need to do in this case, we're starting at 3. So the count's going to be 0, mix is going to be 1, then 3, then 4, then 2. So then the first value, so we want to count from 1 to 4. So we have a look back up at our pseudocode. So the next one, so we've got our 3. So then in index 3, the value is 4. So therefore, we place a 4. We place a 4 in this row. And then in mix 3, we're just going to say 3. Okay, and then 4, we're going to go into index 4. And the count is going to be a 1. So how do we know that? 4 is going to be a 1. So what we've done, gone into index 4, and we're going to count is it equal to 1. So then the value, which means a value, we're going to end that up with a 2. So we're going to end that up with a 2, and then the count, and which means the index is going to be a 2, and the count is going to be a 2, and the mix 4, we're going to have a 1. And then the next value is going to be a 3. Next value is going to be a 3. The mix is going to be a 2, meaning the count is going to be a 3, and the index is going to be a 3. So if the index is a 3, the mix is going to be a 2, which we've got. So then the final value is going to be a 2, and then that's going to be, so if we go down here, the final one, so 3, 3, 3, and we got our 2. And then the other next count, we're going to have 3 in the 3 in the count, 3 in the 3 in the value, 3 in the index, and then we're going to have count 4. So we're going up a count. And in mix 3, we're just going to have a 2. And then finally, the index is going to be a 2. The value is going to be a 2. And the count is going to be a 5 because we've incremented again. And in mix 3, that's going to be a 1. So 4 and 3 is 7, and 2 is 9, and 1 is 10. So in mix 4, after that, the final one is going to be a 10. So we would get 1 mark for the final iteration of count equal to 5. We've got the index count and array as shown, plus mix 4. You would get 1 mark just for initializing the row, and then 1 mark for doing all of the, and then lots of marks for doing the iteration. So you get 1 mark for the initialization, 1 mark for the last part, and the other 4 marks, everything else in between. Okay? Question 6. So we've got a procedure, create files. We'll take 2 parameters. So we've got a string with a file name, integer representing the number of files to be created, and a procedure that will create a number of text files specified. Every file has a different name. Each file name is formed by concatenating file names with the suffix based on the file number, and that suffix will have 3 characters. Create files. Test data 3 results in the creation of 3 files. Each file has a single line. So if we were to do test data 002, that's going to contain the string, this is file test data 002. So we need to write the pseudocode for creating the files. So we need to assume both parameters are valid and that the integer values are between 1 and 999 inclusive. So let's have a procedure. Create files, name root, string, num files, integer. And then just do that. That would get us 1 mark in the bag. Okay? What I am going to do is So that's literally all that it wants us to do. Then we need to declare file name and the suffix as a string. Then we need to declare count as integer. Then we want a loop. So this is a count controlled loop. So we're going up to the number of files. So we know how many times we want it to loop. So we want suffix to be set to num to string. And we're going to pass count. And then we want while the length of the suffix is not equal to 3. What we're going to do, we're going to do 0 ampersand suffix. So we're literally setting the suffix to be 0 and the suffix, so we're concatenating them together. And then what we want is file name is going to be the name root, and using concatenation, but the and, that's going to be a suffix. And then we want an open file called file name, and we're going to we're going to write into it. And then we want to write file name. So we're writing the contents into the file. And then close file, self-explanatory. We're just going to close the file. And then what we want to do is we want to show the next iteration. Okay. So that is literally what we got. So that is our pseudocode worth 6 marks. 1 mark just for the procedure and end procedure. 1 mark for looping the number of file iterations, so it's the for loop, count control iteration. 1 mark for attempting the num to string count, so the file name, trying to get the file name suffix. Another mark for the correct file name, completely correct. 1 mark for open file in write mode and the close in the loop. And then the 6th mark would be the write initial first line to the file in a loop. Okay, so we're opening the file, writing to it, and then we're closing it. And it's all in that for loop. And that is our pseudocode with parameters being valid and the integer values between 1 and 999 inclusive. And that's our code. Okay, so we're going to module check files, counts the number of files produced by create files in part A. So it's relating to the pseudocode we just did. So we have to check the files. It will take a string representing the file name and return the number of files to be found. So we're going to identify the module that should be used to check a file. And that module is going to be a function. Because if we want to return, you need a function, not a procedure. Write the module for the header for check files. So be function, check files, name root, string, and then that's going to return an integer. So that's literally what we want in there. And then state the file mode that should be used to check the files. Read. So reading, we're just reading the contents in the files. We're not doing anything else to it. We're just reading what's in there. And those are our 3 marks, straight in the bag, bosh. Number 7. So we've got 6 modules in a program. So we need to complete the structure chart for these modules. So we need to have a look at these 6 modules and complete the said structure chart. That looks like this. So if we have a look at this structure chart, so we're filling in these boxes for 4 marks. So we got module A. So if we have a look at the other modules, so we know in here, module X calls reset, module Y calls restore. So we want module X to be the first one. Here we want to restore, so we want module Y. So we've got that in there already. And there is a lot more to it than that. So what we are going to need, that is going to be our S2. And then down here, that's going to be our T1. Down here, that's going to be our SA. This is my rough drawing, by the way, because I cannot draw to save my life. SA. And then that's going back up. That's going up. And then what we've got to do here is that's going back up. So this is an A. Going down again. So that's our R and B, which corresponds to here. And then here we got, this is our old code. And then here we just got code. And then here for module X, we are just resetting. So I didn't want to do a rectangle. So we're just resetting in here. Module Y, we're just restoring that. So here we want to type in restore. And here in module Z, that's just going to return an integer. So we want to go in here to module Z. So that will get us 4 marks for that structure chart. So you need the parameters with the labels, module X, and in between the module X and the reset. Same with module Y, which will restore and return the values from module Y. And then module Z is just going to return stuff from module Z. Okay? You just have to excuse my terrible drawings because I cannot draw to save my life, but that's a rough idea. Yep, and then what we need to do is then explain the meaning of the diamond symbol that we've used in the diagram for part A. So the diamond means that module A calls either module X, module Z, or module Y, and whichever one is called will be decided at the runtime. So you get 1 mark for referencing selection, such as if statements, and 1 mark for naming those modules correctly. So I named the modules correctly, that's 1 mark. Said about selection, 2 marks. Although it's not, if you want to be absolutely sure, you could just, if you want to be absolutely sure, you could say through selection. So you could say it means that module A calls either X, Z, or Y through use of selection. So use of if statements. If you wanted to be more direct, more sharp. Blank page. Question 8. So question 8. Class of students, the development of a program to send data between computers. Many computers are connected together to form a wired network. Serial ports connect one computer to another. Each computer is designed assign a unique 3-digit ID, has 3 ports, each identified by an integer value. It's connected between 1 and 3 other computers. Data is sent as individual message strings. Each string has a destination ID followed by the data. Messages will pass through several computers on their way to their destination. When it arrives and is not a destination, the program needs to forward it to another computer using one of the serial ports, which is obtained from the information stored in the array root table, which is a global 2D array of integers. It's declared in pseudocode. So we declared root table as an array, as a 2D array of integers. So the first 2 columns define 1D values. Column 3 gives a corresponding port number to use when forwarding the messages to a computer with an ID within this range. So I should have said ID, not 1D. So this is our root table, an example contents that we could have. So a message will arrive with a destination ID of 283. That will be forwarded using port 2. Row 3 shows an unused row, and that can occur anywhere. And they'll have column 1 set to -1. The value of unused elements in the other 2 columns will therefore be undefined. So the programmer has defined the first program module as follows. So get port. So we need to write pseudocode for that module. And we need to assume that destination ID is valid for a 3-digit string. So we then need to have function get port. And we want to have destination ID. That's going to be our parameter. And then obviously we're going to have return port, and then we're going to have end function. So that's what we got at the beginning. So we want port, root table, and that's going to be 1 to 3. There we go. So we got get port, this destination string, that's going to return an integer. And then we want to declare the index, the dnum, and the port. So this is what we want. So that is what we're looking for. So we need to declare the index, the dnum, and the port, all as integers. And then we're going to want an if statement, which is a very long one. So what I'm going to do show you that. Yes. So you can see how that works. Then we're going to have port table, 1 to 3. Then we're going to have end if. Okay, so that's the first bit. That's the first one, and there's a whole load of others. So obviously we need to go up to 6, which would look, so by the end you need something like this. So you would need if root table 2, 1, minus 1, and root table 2, 1. So you basically need to work out every single combination. Okay? Yep, so that is a mouthful. So that is what we got so far. So we got a function, and this is a massive function, this. Yep, so I'm going to scroll down for that reason, because it is it's a big program, and that's a 7 marker. So obviously you need root, then you got root table 4, 1, then it's going to go to 5, 1, 6, 6, 1, and it's also going to have 6, 2 as well. Because it's 2D, we need to take into account all of the conditions that are set, and we need to set the port to each aspect of the root table. So this is how we would do it. So that is literally the whole bit of code you would need to have. So I'm going to scroll out, go up, and show you the whole code that they're looking for. Because this is a really, really tough one, this. So writing the pseudocode for get ports. So you've got parameters as destinations as a string, and that's meant to return an integer. So we declare the index, the dnum, and the port as integers, and we set dnum string to num, and we're passing this destination. And we set the port variable to -1. So what this is doing, we're going from 1, 1, if root table is 1, 1, 2, 1, so column 1, row 1, column 2, row 2, column 3, row 1. So row and column. So all of these are column 1s, and these are row 1, row 2, row 3, row 4, row 5, row 6. So it's looking for all of the rows in column 1. If any of these are -1, and the root table is in those rows in column 1. So say it's 1 and 1, and root table is, if they are greater than or equal to dnum, and the root table happens to be row 1, column 2 is less than or equal to dnum, then we're setting the root table at row 1, column 3. And once you understand this if statement, the others should fall into place. So you're literally counting up the rows, using those as column 1s, counting up the rows here, and you're counting the number of column 2s. And then once we ended all of these ifs, we're going to return the port based on this entire function. It is a mouthful to take in. But that sort of answer will get you 7 marks. As paper 2 is tough. 8b. So we got copies of the same program will run on each computer. So the program will have a global variable myID of type string, which will have a unique ID of the computer which the program runs. When messages are received, they are placed on one of 2 stacks. Stack 1 is used for messages that have reached their destination, and stack 2 is used for messages that will be forwarded onto another computer. So we've got a module stack message, which is already written, and we've got process message. So you need to read the descriptions of what each of them do. So we've already written this. So in the scenario, stack message is written. So we need to write process message. So it takes message as a parameter of type string, ignores any message with a 0 length data field, extract the destination ID from the message, check whether the destination ID is the computer or whether the message needs to be forwarded, and it's going to use the stack message to add the message to the appropriate stack and output an error if it's not added to the stack. So we need to literally write pseudocode for processing that message. So, procedure, process message. We're going to pass this message as a string, and then we're going to end procedure. That's our 1 mark. Then we're going to declare this dest as a string, and we're also going to declare response as a boolean. So how's a politician not answer a question? Then we're going to declare stack num integer. Then we need to find out if the length of this message is greater than or equal to 4. Then there's going to be this dest left this message, and that's going to be 3. And then we want the and then for the computer, if this destination is my ID, then what we're going to have is we're going to have stack number is equal to 1. And then we're going to have else stack is equal to 2. Then we're just going to end the if. And then we need to have a variable called response. And we're going to call the stack message, and it's going to pass this message and stack num. That's the integer we just declared. And then if response is equal to false, then. Then we need to output message discarded, no room on the stack. So this is where we are checking that the stack is full. And then we want 2 end ifs, and then we've literally ended the procedure. So this is a 7 marker. So you would get 1 mark if you ignore the message if the data field is empty. You'll get 1 mark for attempting to use the stack message. 1 mark to test text stack message return value for both cases. You need to test if the destination is this computer. So that's 1 mark. We need to extract this destination from this message. And then following a reasonable attempt, we need a warning if the stack message is false. Okay, so this pseudocode, or something like it, will get you 7 marks. And then last but not least, 8C part 1 and 2. So the program contains a module, getFile, which receives text files sent from another computer. So lines from the file are sent one at a time. Each message will have 1 line, process message, from part B, and each message is received onto stack 1. Lines from the file are sent one at a time. Each message has 1 line and writes the data to a text file. But the problem is, under certain circumstances, the received file does not appear as expected. So we need to assume that while the flag file is being received, process message receives only messages containing lines in the file. So you will get 1 mark for naming the circumstance, 1 mark for 2 marks for an explanation. So we need to decide on a scenario. So we could say something like, if the stack is full. So I would say if the stack is full, then not all lines can be stored on the stack. So the file will not contain all of the original lines. That's literally what I would say. You could also have, if there's more than 1 line, if more than 1 line is on the stack, stored on the stack operates a first in, last out data structure. So that is going to be, so the lines will appear out of sequence. Another scenario you could have is all the data in a line, red, cannot be stored on the stack. So the stack elements won't be allocated enough memory. So part of that line is going to be stored in the file. Another scenario which I would also have would be stack is empty. So that means stack is being read faster than it's being written. So you're going to have blank lines inevitably inserted into the file. But if it was me, I would have if the stack is full or if the stack is empty for my 3 marks. Last but not least, 1 marker to end the paper. Suggest a more appropriate abstract data type that could be used to store the messages that won't have the same problem. That's a Q. And on Q, we have finished the November 2023 AS Level Computer Science past paper for the Cambridge exam spec for AS Computer Science, paper 2. Phew! Okay. Please remember to click that like and subscribe button and press the notifications bell. Share that video far and wide, especially if you want your peers to pass. And thank you very much for watching this video, and I look forward to seeing you on the next one. Thank you. Bye for now. So please be sure to hit that like, and please also remember to hit that subscribe button. And another way to subscribe is to just click on this link, which is below each video I place. And if you like my content and you want to find out more about what I do, I've also got an online course called Introduction to Computer Systems on the Udemy website. So you just need to click on it. And there we go. So this is my online course, Introduction to Computer Systems. So this is the landing page for that course. So in it, you will learn. So these are some of the things we'll learn, like explaining the role of the central processing unit, describe the components of the CPU, provide an introduction to assembly language, which is low-level programming, explain the factors that affect the performance of the central processing unit, and I've also put in another bit that I'm interested in, the physics of overclocking the CPU, which made me develop an interest in electronics and also physics. So there's a lot more to it than even we realized. So this is the course content. So you've got computer systems, so I'm introducing you to it. Then I'm going into the different forms of architecture and assembly language. Then I'm going into the factors that affect it and the physics of overclocking the CPU. And then I'm going into logic, so combinational logic systems, making the logic gates, sequential logic systems, semiconductors. Then I go into all things binary, where we introduce you to number systems, all the way down to doing binary and sound, images and text. And then finally we got input and output devices and the different forms of storage, so that's where memory will come in. And then my assessment is basically one big quiz of 30 questions. So you don't need any knowledge to do this course. All you need is a computer with a stable internet connection. So that's all you really need there. And why you should do the course? Well, wherever I don't know, I'll go out and learn it. So the way my brain is wired is I'm on the autism spectrum. So it will be an asset in helping you get through the online courses that we provide. So we understand how to explain things in simple terms due to my teaching background. So you could think of us as a real-life version of, say, a Sheldon Cooper from Big Bang Theory, minus the rudeness, or a C-3PO, but without the glitches. So I'm on the autism spectrum, so we're on the autism spectrum and have a rough idea on how to talk to them and relate to them. And my teaching style is that style I've crafted and one that works in a way that some people don't get if they only had to